In the early 2000s, the idea of talking to our devices felt like something out of science fiction. Yet, behind the scenes, tech giants were working on a revolution that would bring AI into our everyday lives. It all started with virtual assistants, programs like Siri, Google Assistant, and Alexa. These digital companions were designed to respond to voice commands, turning complex algorithms and data processing into simple, human-like conversations. But how did this come to be? Siri, one of the earliest breakthroughs, began as a humble project by a small startup. In 2010, Apple saw its potential and acquired it, quietly embedding the technology into the iPhone. By 2011, Siri became a household name. You could ask her for directions, weather updates, or even tell her to send a text. What seemed like magic was the result of cutting-edge natural language processing and machine learning, allowing AI to understand and respond to human speech in real time. But Siri wasn't alone. Amazon soon followed with Alexa, a voice assistant embedded in their Echo devices. Suddenly, we had AI controlling everything, from turning on lights to setting reminders, shifting our relationship with technology forever. These were just the first whispers of what AI could do, but they laid the foundation for a world where intelligent machines would become our everyday companions. This era marked the dawn of AI assistants, a seemingly simple idea that would pave the way for far more complex applications, from helping us with daily tasks to the intelligent systems that drive our cars. These early innovations were more than just conveniences. They were the seeds of a technological revolution that was only just beginning. Behind every simple, "Hey Siri" or "Alexa, turn on the lights," lies a sophisticated dance of data and algorithms. But how did machines learn to understand human language? The answer lies in the incredible field of natural language processing, NLP, which turned human speech into something a machine could comprehend. It all begins with speech recognition, where AI listens to the sound waves of our voice, breaking them down into individual words and sentences. But recognizing words is just the first step. For AI to truly understand us, it has to grasp the meaning behind those words, a far more complex task. This is where machine learning comes in, allowing AI to not only process the words we say, but also learn from context, improving over time. Take Siri, for example. When you ask, "What's the weather today?" Siri doesn't just recognize the words weather and today. She also understands the relationship between those words and your location, processing this information to give you a relevant answer. This ability to extract meaning from speech is what sets modern AI apart from earlier systems. Early voice assistants struggled with accuracy, often misunderstanding requests or failing to respond naturally. But as machine learning models evolved, AI began to mimic human conversational patterns. It could handle multiple meanings, like understanding that "Can you open the window?" might refer to a browser window in one context and a literal window in another. These breakthroughs were fueled by vast amounts of data, millions of interactions that helped train AI systems to recognize and predict the most likely responses. However, learning to talk like humans is just one piece of the puzzle. These systems also needed to learn from mistakes. That's where deep learning and advanced algorithms came in, allowing AI to continually refine its understanding of language. Every time you use an AI assistant, the system is quietly learning in the background, improving with each interaction. This monumental leap in understanding human language wasn't just a technical achievement, it was a turning point for AI as a whole. As machines learned to talk, they unlocked the ability to engage with us in more natural, intuitive ways, setting the stage for even more complex applications in the future. But this was just the beginning. The same technology that allowed machines to understand our voices would soon be applied to more critical tasks, like navigating a car through busy city streets, where lives depend on the machine's ability to make split-second decisions. Imagine a car that drives itself. No hands on the wheel, no foot on the pedal. What feels like science fiction is now becoming a reality, thanks to the remarkable advances in AI. But how exactly does a car learn to navigate busy roads, avoid obstacles, and keep passengers safe? To understand the magic behind self-driving cars, we need to take a deep dive into the intricate world of autonomous vehicle technology. At the heart of every self-driving car is a powerful AI system that acts as the brain of the vehicle. This system processes an overwhelming amount of data in real time, using a combination of sensors, cameras, radar, and LIDAR to create a 360-degree view of the world around it. These tools allow the car to see its environment, from detecting nearby vehicles to recognizing pedestrians crossing the street. But it's not enough for a car to just see. It has to make decisions. This is where deep learning comes into play. Deep learning models, trained on vast datasets of driving scenarios, allow the car to identify patterns and predict outcomes. It can decide when to brake, when to change lanes, and how to navigate complex intersections, all within milliseconds. It's this predictive power that makes AI-driven vehicles so remarkable. Yet, driving is about more than just reacting to what's directly ahead. Self-driving cars rely on advanced algorithms that allow them to anticipate what might happen next. For example, if a pedestrian suddenly steps off the curb, the car's AI system is already prepared to slow down or stop. This level of predictive analysis is one of the reasons why autonomous vehicles are said to have the potential to reduce human error and make roads safer. However, the road to perfect autonomy hasn't been smooth. Engineers have faced significant challenges, especially when it comes to unpredictable environments like bad weather or human drivers who don't always follow the rules. To overcome these hurdles, companies like Tesla and Waymo have continuously refined their AI systems, testing cars in a variety of conditions, from bustling city streets to remote highways. These self-driving systems learn from every mile driven, not only through their own experiences, but also by collecting data from thousands of other vehicles on the road. This shared learning process, known as fleet learning, helps improve the AI's decision-making capabilities and adaptability over time. Self-driving cars aren't just a glimpse into the future. They represent the evolution of AI from passive assistants, like Siri, to autonomous machines capable of critical, life-or-death decisions. As AI continues to advance, the dream of fully autonomous vehicles is inching closer to reality. But the question remains, when will we trust these machines enough to take our hands off the wheel completely? The answer may come sooner than we think. Driving a car isn't just about knowing the rules of the road. It's about being able to see and interpret the world around you. For self-driving cars, this presents one of the greatest challenges, teaching machines not only to see, but to understand what they're seeing in real time. This is where the power of computer vision comes into play, giving autonomous vehicles the ability to process visual information as a human driver would, only faster and with more precision. At the core of this technology are cameras, strategically placed around the car to capture a full 360-degree view. But these cameras don't work alone. They're supported by LIDAR, a system that uses lasers to map the environment in incredible detail, even in the dark or poor weather conditions. Together, cameras and LIDAR help the car see everything from road signs and traffic signals to other vehicles and pedestrians. But simply capturing images isn't enough. The real magic happens when AI algorithms take over, interpreting the visual data and converting it into actionable decisions. This is where the car's brain shines. When you or I look at a street, we see a mixture of objects, cars, people, signs. A self-driving car, however, sees it in layers, breaking down the environment into categories: moving objects, stationary obstacles, road markings, and even subtle cues like a pedestrian about to step off the curb. For instance, as the car approaches an intersection, it must process multiple layers of information at once. It identifies the stop sign, calculates the distance to the nearest car, and recognizes whether a cyclist is about to cross the street. All of this happens in milliseconds, thanks to convolutional neural networks, CNNs, a type of deep learning model designed to mimic how the human brain processes visual information. One of the biggest challenges in computer vision is understanding not just what an object is, but what it's likely to do next. This is where predictive algorithms come in, allowing the car to anticipate movements, like a vehicle merging into its lane, or a child running after a ball. It's this predictive power that enables self-driving cars to not only react to the world around them, but to stay one step ahead, preventing accidents before they happen. Despite all these advancements, computer vision isn't foolproof. Poor weather conditions like heavy rain or fog can still interfere with sensors, and unexpected human behavior, like jaywalking, can throw off even the most advanced AI systems. Engineers are continually working to improve how machines handle these unpredictable scenarios, pushing the boundaries of what computer vision can achieve. The ability for machines to see has taken autonomous driving from a distant dream to a fast, approaching reality. Yet it's not just about replicating human sight, it's about surpassing it. With AI-powered vision systems, autonomous cars are learning to see the world in ways that even the best human driver can't, unlocking the potential for safer, more efficient roads. The next time you see a self-driving car on the road, remember, it's not just following a map, it's seeing, thinking, and learning in real time. It's hard to believe that the same technology that helps us set reminders and play music could also be driving cars, but that's exactly the journey AI has taken, from simple voice recognition in devices like Siri to the complex, decision-making systems behind self-driving cars. This evolution didn't happen overnight. It's the result of decades of progress in machine learning, data analysis, and advanced algorithms. It all started with basic conversational AI, the ability of machines to understand and respond to human speech. When Siri was first introduced, it marked a huge leap forward in how AI could interact with us. But what seemed like a helpful voice assistant was actually a glimpse into something much bigger. The same natural language processing, NLP, that allowed Siri to understand spoken commands was the foundation for AI systems to process other kinds of data, like visual inputs and sensor readings in cars. Over time, AI systems moved beyond just recognizing words and started making decisions based on patterns, learning from every interaction. This concept, machine learning, allowed AI to analyze huge data sets and improve over time. In voice assistants, this meant more accurate responses. In autonomous cars, it meant understanding complex environments and making critical choices in real time. Imagine it like this. Siri listens and responds based on what you say, but a self-driving car must listen to the entire world around it. It reads data from cameras, radar, and LIDAR, constantly making decisions on the fly. Yet, both are driven by the same core AI principles, analyzing data, learning from patterns, and making predictions based on input. The transition from virtual assistants to autonomous vehicles is a perfect example of how far AI has come. It shows how machines, once limited to simple tasks, like answering questions or setting alarms, have evolved into systems capable of processing real-world data with incredible complexity. The technology that once lived in your pocket is now driving vehicles, managing traffic, and possibly saving lives. As AI continues to advance, the line between these applications will blur even further. The decision-making power that drives autonomous cars could soon be applied to everything from medical diagnoses to managing smart cities. What began as an assistant has now grown into something far more powerful, a machine with the potential to think, learn, and act in ways that were once thought to be purely human. And as we look to the future, it's clear that this AI journey is only just beginning. From the simple tasks of virtual assistants to the life-or-death decisions of self-driving cars, we are witnessing the dawn of a new era where machines don't just assist us, they become an integral part of our world. As self-driving cars move closer to becoming a mainstream reality, they bring with them a host of complex ethical questions, questions that challenge the very nature of decision-making. How should an AI system handle life or death scenarios on the road? What happens when a car must choose between protecting its passengers or pedestrians? These dilemmas go beyond technology and venture into the realm of morality, where human lives hang in the balance. Imagine a scenario where a self-driving car is faced with a sudden, unavoidable accident. Should it swerve to avoid a pedestrian, risking the lives of its passengers, or protect those inside at all costs? This is known as the trolley problem in ethics, where AI is forced to make decisions that would be morally challenging, even for a human. The difference is that a human has instincts and emotions, while AI follows programming. But who decides what those algorithms prioritize? One of the biggest concerns surrounding autonomous vehicles is algorithmic bias, the potential for the car's decision-making process to be influenced by biased data or programmed priorities. For example, if a car is trained using data that doesn't represent diverse scenarios, it could make decisions that are less safe for certain groups of people. This has sparked debates on how to ensure fairness and transparency in the AI systems that control these vehicles. Furthermore, the legal responsibility of self-driving cars introduces another layer of complexity. If an autonomous vehicle is involved in an accident, who is at fault? The car, the manufacturer, or the programmer behind the AI? Traditional legal frameworks struggle to adapt to these new technologies, raising concerns about accountability and liability. Regulators are now tasked with creating laws that keep up with the rapid pace of innovation while ensuring public safety. And then, there's the question of trust. Can we fully trust machines to make the right decisions in critical moments? Self-driving cars are designed to minimize human error, but they're not immune to technical failures or unexpected events. While AI can process information faster and more accurately than a human in many cases, it lacks the intuitive judgment that humans possess, judgment shaped by life experience, emotion, and empathy. These moral and ethical dilemmas are more than theoretical. They are at the heart of the debate over whether society is ready to embrace autonomous vehicles. How do we program morality into a machine? And, more importantly, do we want machines to make such profound decisions for us? As we move further into the age of AI-driven cars, these questions will only become more pressing. Engineers, ethicists, and lawmakers are now grappling with how to balance technological progress with the moral responsibilities that come with it. One thing is clear: the road to a fully autonomous future is not just paved with technological advances, it's also lined with ethical challenges that will define the very nature of AI's role in our society. The story of AI is far from over. In fact, we're just scratching the surface of what artificial intelligence can do. From personal assistants that learn our preferences to self-driving cars that navigate the complexities of our roads, AI has already transformed our world in ways that once seemed impossible. But where do we go from here? What's next in the AI revolution? The future of AI lies in its ability to learn and adapt at an even faster pace. We're heading toward a world where AI is more personalized, intuitive, and integrated into every aspect of our lives. Imagine a virtual assistant that doesn't just answer your questions but anticipates your needs, scheduling your day based on your habits, suggesting meals based on your dietary preferences, or even managing your home's energy use to lower your carbon footprint. This is the promise of context-aware AI, where machines understand not only what you're asking, but the entire context of your life. In the world of transportation, the shift to fully autonomous systems is inevitable. Today's self-driving cars can already handle most driving scenarios, but tomorrow's vehicles will take this even further. Smart cities will emerge, where AI-driven cars communicate with each other and the infrastructure around them. Traffic lights, road signs, and even parking spots will be part of a vast, interconnected network, minimizing accidents, reducing congestion, and improving urban mobility. The future of transportation isn't just about self-driving cars. It's about creating a seamless, intelligent environment that supports them. But perhaps the most exciting frontier is the potential for artificial general intelligence, AGI, machines that can think and learn at a human level, capable of performing any intellectual task a person can. While current AI is highly specialized, AGI would represent a giant leap toward machines that could understand the world as we do, solving complex problems across multiple domains. This would revolutionize fields like medicine, science, and education, where AI could discover new treatments, advance our knowledge of the universe, or even reshape how we learn. Yet, with these incredible advances comes a new set of challenges. As AI becomes more powerful and integrated into society, questions about privacy, security, and ethics will continue to dominate the conversation. How do we ensure that these systems are used responsibly? How do we protect against misuse? And most importantly, how do we keep humans in control of machines that are growing smarter by the day? The AI revolution is unfolding before our eyes, and we're living in a time where the impossible is becoming possible. From personal assistants to fully autonomous systems, AI is reshaping industries, improving lives, and redefining what it means to interact with technology. The future is bright, but it's also uncertain. As we move forward, one thing is clear: AI is here to stay, and the journey is just beginning. The only question that remains is, how far will we let it take us?